In this video, I will go over the homework 3.2 solution, some of them. Number 1 is finding the integral and antiderivative from 2x ds, and the given f of x equals to x squared plus 5. So in this case, this is the antiderivative is equal to the capital fx function, so should equals to f of 1 minus f of 0, the capital X. In this case, f of 1 is equal to 1 plus 5. This is our f of 1, and then 0 squared plus 5. I would like you to put a parenthesis since there's a subtraction. Whenever there's a subtraction or even addition, I want you to get used to have the habit to put a parenthesis when you're subtracting a function, because the sign inside that function is going to change. So I have a 1 plus 5 minus 0 minus 5. So that gives you a 1. Let's do another one. Number 5. Number 5 is the integral from 1 to 4, 3x squared dx. Oh no, that's number 2. Let's do number 5, because number 2 is similar to number 1. So number 5, we have from 1 to 5, 1 over x dx. And then f of x equals to ln x. So the antiderivative of 1 over x is equal to the natural log of x. Sometimes you will need to add a constant, but in our case, the constant, since it is a given function, so the constant is considered 0 in this case. So this is equal to f of 5 minus f of 1. So I have ln of 5 minus ln of 1. That's it. You can try to find what's the natural log of 5 minus natural log of 1 equals to what. Or you can just keep it as this. That works. Now, let's do number 6. So for number 6 is given you the integral 8 of x equals to from 0 to x and then 2t dt. And they want you to find a prime of x. If it's a prime of f, that means they want to find the derivative of x, not t, even though the function inside of this is t. But we treat t as a constant in this case. By the fundamental theorem of calculus, a prime of x is equals to d over dx, since you're trying to get the derivative at x, from 0 to x to t dt. Or let me just write down the definition. From a to certain number x, f of t dt equals to f of x. If ax equals to from a to x, f of t dt. So that's the fundamental theorem of calculus. So in our case, a prime of x, let me use the green pen since we were starting with the green ones. We have a prime of x equals to d derivative at x from 0 to x 2t dt, which is equals to 2x. Okay, that's number 6. Number 7, very similar. We have 8 of x equals to the integral from 0 to x, 3 minus t, and derivative at t. And I want to find a prime of x. So we're going to apply the fundamental theorem of calculus. So a prime of x is equals to the derivative of the integral from 0 to x 3 minus t dt, which is equals to 3 minus x squared. Oh, I forgot there's an t square in here. Okay, now number 8. Number 8 is let a of x, the original function, is equals to the integral, not the original function, sorry. The capital A of x is equals to the integral from 0 to x, f of x, f of t, at dt. And now we want to find a prime of 1, a prime of 2, a prime of 3. And they've given you the function here. And I'm going to label each dot 2, 2. This one is 1, 1, 3, 2, and 4, 1. And this is the function f of t. So the graph is giving me f of t, so that means a prime of 1 is equals to f of 1, in our case, is equals to 1, is our first dot, and then a prime of 2 is equals to f of 2, which is 2, is our second point in here, and then a prime of 3 is equals to f of 3, which is also equals to 2. Is this dot. I'm going to use a different color of pen so we will be able to see it. All right. Now, number 9. Number 9 is giving you a graph. And the graph is the first derivative. G prime of x. For the first one, I'm going to go over number 9. Is a decreasing function. So now they want you to sketch a graph of g of x. We want to sketch a graph of g of x. So now let's analyze the g prime of x first. When we analyze it, we need to look at which part g prime of x is greater than 0. So from this part, from 0, from x from 0 to 2, g of prime, not ff, sorry, g prime of x is greater than 0 because it's above x-axis. That means we're expecting an increasing function, so that means g of x is increasing from x equals to 1 to x equals to 2, from x equals to 0. Another thing we need to be careful is how fast they increase. Well, as you can see, at first, this is g of prime is equals to 3, and then here, g of prime is equals to 0. To be more accurate, should be g prime of 0 equals to 3, g prime of 2 is equal to 0. So that means at x equals to 1, we have a critical point. We don't know if it's the maximum or minimum yet. Another thing we need to be careful is the slope. At beginning, if you look at 1, g prime of 1 is less than g prime of 0. That means when the graph is increasing, but the slope is getting flatter, right? is going to be getting slower. So the graph is more like looking like this way, because at the beginning you are increasing faster and you slow it down. Your accelerating speed is slowing down. Okay, that's something that we also want to know that. Okay, now the second part is when they below the x-axis in here, after 2, when x greater than 2, g prime of x is less than 0. It's below x-axis. If it's below x-axis, that means the original function g of x is going to be a decreasing. Okay, now second thing I want to analyze is the second derivative. So we know that if the first derivative, we take a derivative of the first derivative, we will get the second derivative. To write this down, so g double prime is equal to g prime, and then take a derivative. In this case, basically is the slope of g prime of f of the graph. So now let's take a look at the slope of this graph. It's going to be negative, right? Because the graph is going down. So now we know that the second derivative is negative. That means it's less than 0 from 0 for all x. That means what? This is going to be a concave down. Well, now get back to that critical point. G double prime of x is going to be concave down for all x. So no matter what x is. So that means that critical point is going to be a maximum. Now, we can start our graph. So our graph should look like this way. Going up, and then slow down, reach the maximum point, and then go down. So the whole graph is going to be concave down. So that's how you graph it. I think you should be able to try number 10 by yourself. It's the similar idea to analyze the graph. You need to have a g of x, figure out from g prime of x to have a g of x, and then see how do you get the second derivative of this graph. Okay, that's it for this homework solution. Let me know if you have more questions.